Welcome and good afternoon to all our speakers and online participants. My name is Blanca and I will be your host in today's online program entitled The Role of Technology in Vietnam's Massive Oil and Gas Industry. We are honored to have with us two prominent and leading figures of the oil and gas industry who have taken their time to be with us. This webinar is organized by Fireworks Trade Media Company Ltd, together with Asia Webinars, and brought to you by Aviva. Aviva has over 50 years of experience in software solutions and innovations for companies and energy industries, empowering customers to save up to $320 million per year. They help customers achieve superior performance by driving value, agility, and sustainability throughout their asset and operations cycles. We enable 90 of top 20 petroleum companies, over 300 refineries, most of the world's petrochemical crackers, and 900,000 miles of pipeline with the most comprehensive, integrated, and unified operations.
People rely on your business to deliver the essentials of life every day, sometimes every second. Digital transformation is accelerating your ability to support this demand. What if even more profound opportunities lie ahead? What if the strategy you're only beginning to conceive could be enhanced through instant AI insights driven by data all around you, easily shared and enriched, not just with colleagues, but also your best suppliers, partners, and customers? Imagine seamlessly transitioning from designing today's engineering project to delivering and optimizing tomorrow's products and processes, each generation getting better through continuous learning. This is the future, and it's nearly here. At Aviva, we want to help you take the lead in this new, connected industrial economy. Let's unleash your data from traditional boundaries and use it to turn your network into an intelligent, agile, and secure ecosystem. Collaborate better with trusted partners, reduce integration costs and delays, anticipate curveballs, outpace the competition, and seize new opportunities across the industrial lifecycle. This is where your sustainable digital future begins. Aviva, we'll take you there.
For more details about their company, please visit www.aviva.com. Aviva, a global leader in industrial software. So I am honored to introduce our presenter for today's program. So we have with us Ms. Loong Hai Linh from Petro Vietnam University, and Mr. Michael Liu, the Senior Pre-Sales Engineer from Aviva. Our program would consist of two parts, starting with the individual topics from our key speakers, then the question and answer portion of the program. After each presentation, our speakers will be accommodating questions from our audience. So to send in your questions while in a meeting, kindly click chat in your screens. This will open the chat on the right part of your screen. Then you can type a message into the chat box and send. Okay. To start with, may I introduce our first speaker. She has interest in oil and gas production, enhanced oil recovery screening criteria, pressure-dependent permeability, pseudo-30 model for hydraulic fracture growth, acid treatment, and reservoir stimulation for pressure prediction. Ladies and gentlemen, please welcome the Deputy Head of Drilling and Production Department, Faculty of Petroleum of Petro Vietnam University, who will be presenting us the topic on the digital trends in the oil and gas industry. Ladies and gentlemen, it is an honor to present Ms. Loong Hai Linh.
Okay, thank you. Thank you very much for introducing me. So let me share screen, right?
Yes, ma'am, please. Thank you.
Thank you. Okay, can you see my screen now?
It's crystal clear, ma'am.
Okay, thank you. So, hello everyone. My name is Hải Linh, Deputy Head of Petroleum Engineering at Petrovietnam University. And it is my honor to be here to present a topic about digital trends in the oil and gas industry. So, I will go through a bunch of slides from overall of digital transformation to digital trends, such as investment in digital technologies in the upstream oil and gas, Deloitte DOT model. And then I will talk about digital terms and initiatives such as some new technology applied in upstream and downstream oil and gas industry. And finally, some suggestions for Vietnam to apply digital transformation in oil and gas industry. And to start this topic, we need to understand what is digital transformation. You've probably heard at least once about digital transformation, right? So digital transformations is the integration of digital technology into the operations of businesses and organizations to fundamentally change the way they operate business models and provide new values for customer. So technology of fourth industrial revolution are reshaping the global economy, including energy, by employing a variety of cutting-edge technologies, as you can see here, from artificial intelligence, big data and analytics, to unmanned vehicles, blockchain, and Internet of Things. Businesses can benefit from data-led insight, respond in real time to new challenges, and boost efficiency and productivity. And together, these cutting-edge technologies are transforming the world of work. And so now, as oil price and oil demand are falling, the COVID-19 pandemic is exacerbating the situation, and long-term challenges such as working agendas, budgets, and also climate change are overwhelming to the oil and gas industry. So oil and gas enterprises have many pressures and opportunities to improve efficiency and reduce production costs. Through the greater adoption of digital platforms and digital applications, along with the field data generated from existing infrastructure, the oil and gas businesses will have a better chance of overcoming the challenge of the future and helping the oil and gas industry continue to develop. So, so here we have concrete numbers to show obvious benefits of digital transformation here, both economical and environmental benefits. According to the analysis of the World Economic Forum in the period 2016 to 2025, digital transformation can generate about $1 trillion for oil and gas companies and contribute about $640 billion to society. Moreover, environmental benefits include reducing emission of about 1,300 million tons of carbon dioxide, saving about 800 million gallons of water, and avoiding oil spill equivalent to about 230,000 barrels of oil. So, so here we can have 6 main benefits of digital transformation in oil and gas industry. Opening up new business opportunities, increase profitability from capital, improve operational efficiency, managing an aging workforce, and reducing safety costs. And the last one is a quick response to market fluctuations. So how about the digital trends in the oil and gas industry all over the world? In the figure 1 show the investment in digital technologies, and here we can see that the oil and gas companies that invested the most in mobile device in 2016, about 57%, while next 5 years big data and analytics are the trend to be invested the most, about 38%. Oil and gas companies have invested heavily in fully integrating mobile device into everyday operations. I can say that the major benefits of this integration include workflow improvement from better group communication, increased worker productivity, and better recording of file data. Mobile technology also allow us for real-time data monitoring through specialized software on smartphone, and it can have a positive impact on health, safety, and the environment. And big data or analytics is of great interest in the near future because of its cheaper cost and higher computing power. As we know that modern offshore drilling platforms have about 80,000 sensors that can generate 15 million gigabytes of data during the asset's lifetime. So big data and analytics will have oil and gas company navigated this huge amount of data. So in this slide, I will show you a model called Deloitte Digital Operation Transformation Model, or we can say that Deloitte DOT model. So in Deloitte report, the DOT models is a digital transformation roadmap consisting of 3 stages. The first stage is transforming the physical world into digital work, or we can say physical to digital. The second stage is handle the digital work, or we can say digital to digital. And the last one is transfer operating information from the digital work to the physical work, or we can say digital to physical. And these 3 stages we divide into 10 steps. In the first stage, in the journey, we have companies mechanizing the process using hydraulic, pneumatic, or electrical control system. This phase can allow players to anticipate and prepare for failures and unusual conditions. And by this journey then progresses to capturing information from the physical world by sensorizing equipment and transmitting data generated in the field using IT networks. And by doing this, an oil and gas company may be able to respond to field conditions and monitor operation remotely. In the second stage, we have the set of milestone can be achieved when a company breaks operational silos between discipline, realize hidden productivity gains, improve the usability of data, and identify new area of value creation. So for this stage, the transformation should progress from integrating diverse data. We're using cloud servers or data standards. Analyzing and visualizing data, we use new age computers and platforms, for example, big data analytics, wearables, and interactive workstation. I can show you some example of this later in this presentation. And the last phase in this stage is augmented decision making. For example, self-learning machines. In the last stage, this phase start with robotizing facilities and progresses to the crafting of new products to improve precision, reliability, and design aspect of physical assets. And this phase ends with virtualizing the entire asset base by creating digital twins and digital twit. And this journey, this model is conducted as a loop. After applying the 10 steps to a specific object or asset, businesses return to apply it to the whole system of many assets in turn, and finally deploy to the entire ecosystem, including suppliers and also customer. And the 3-stage and 10-step digital transformation journeys is universal for different industry, not only for oil and gas industry, but also for another industry. So depending on the specificity of each field, some steps can be omitted, and the content of each step will have a different content. But in general, this DOT model can consider as a general model. And in the upstream sector in oil and gas industry, as we know that the upstream sector is critical, capable of bringing high added value, and it also the backbone of Vietnam oil and gas industry. So in this sector, in the upstream sector, Deloitte divides into smaller sector via exploration, development, and production. With the exploration phase, we divide into basic stage such as geological prospectivity, seismic imaging, exploratory drilling. With the development phase, we have a field planning, engineering and construction, and development drilling. And with production phase include a well completion, production operations, and well intervention or workover. So putting 10 steps that I said before of DOT model into the 9 stage of oil and gas in exploration and development change, together with the analysis, there is a map of the current status of digital and digital transformation orientation of the world oil and gas industry, as we can see here in slide figure 3. And although digital maturity varies from company to company, the exploration segment of the industry in general is digitally ahead of development and production. We can see here clearly in the figure 3, however, not on subsegment within the exploration segment are ahead. Similarly, there are few subsegments within drilling and production phase that are adapting and getting ready for their digital leaps. With the seismic imaging, for example, I can take an example. With the seismic imaging, you can see here, it is a process the industry has been using for over 80 years in evaluating and imaging new and complex subsurface formations. And this is largely at an advanced stage of data analysis and visualization in the DOT model. So for example, now ExxonMobil is using seismic imaging to even predict the distribution of fracture in tile reservoirs, helping it to enhance flow and optimize well placement. In the development phase, we have development drilling has its own characteristics. Well drilling and completion is mainly carried out by service contractors. So a series of service stage with different content, different goals and methods, together with hundreds of tools, software and copyright technology of different contractors, make the integration of data of the drilling process more difficult in the absence of a common data standard. So this stage is mainly setting the goal of data integrations in this map. For example, Noble and Baker Hughes are targeting a 20% reduction in offshore drilling costs by jointly developing an advanced data analytics system. And the first example I can give here is in the production segment. Unlike exploration and development, the production segment of a company mostly consists of brownfield wells, platforms, instruments, and control system. And about 40% of global crude oil and natural gas production comes from fields that have been in operation for more than 25 years. It's very old. In fact, there are about 175 fields that have been producing for more than 100 years. So they are considering that the continuity of production and the cash flows is the key. So the industry always finds itself in a never-ending cycle of operating and retrofitting. And based on numerous interviews and in-depth research, 4 digital terms have been identified that are expected to play a vital role in the industry digital transformation in the period of 2016 to 2025. That are digital asset life cycle management, circular collaborative ecosystem, beyond the barrel, and energizing new energies. And here as I said before, lower oil price continue to hamper margins. The oil and gas industry is facing intense pressure to improve operational efficiency. So the new era of automation digital initiative is built on the application of different technology like robot, drones, and the development of capability for autonomous and remote operations. And as we can see, here are some case study of a new era of automation, such as robotic drilling system of energy technology in figure 5, cognitive computing in upstream operation of Repsol in figure 6. Using predictive maintenance to anticipate critical equipment followed of Apache corporations in figure 7, and intelligent pipeline technology of Columbia Pipeline Group in figure 8. And moreover, wireless sensors and personal monitoring system that indicate when a worker is continue to evolve and improve for several decades. And now connected workers are employees who not only are empowered with wearable smartphone or connected product, but also are able to fully exploit the data the device produce to carry out their jobs as safely and efficiently as possible. we can see a case study of Schlumberger company with piloting wearables to improve field safety and productivity. So Schlumberger is piloting the use of wearables based on Google Glass to improve the safety and the productivity of field employees. Or we can have the consumer energy choice in energizing new energy. For example, Tesla with the Powerwall, storing electricity with Powerwall. And this figure provides key digital solution that could have an offshore focus company to transform its core operation. We can see in the E&P region office virtualize the ecosystem. That means creating digital twins of offshore assets to increase structural integrity and prototype new and learn structural designs. So also we have a field development planning department in department 2, enable cross-functional workflow or data conversions 3, integrate operation data, and well site drilling monitoring 4, analyze at edge. Or we have 5 or 6 is mechanize and automate equipment, also robotized platform on website. And we have crafting complex parts such as POP stock, manifold, drill bit in the 7th department. So after going through the overview of digital transformations as well as the DOT models and ideas applied in the oil and gas industry around the world, so here are a few suggestions for the digital transformation for Vietnam oil and gas industry. So stemming from the above analysis, the big orientation in the exploration field in Vietnam is to focus on building a data center for exploration and production. This center needs to fully integrate geological, geophysical data, and also develop spatial analysis tools, apply artificial intelligence, machine learning, or optimize location exploratory drilling objects in order to reduce risk reductions. And for new production to assess, we need to consider the design of a sensor system that collect full file information and conduct an analysis. If the field, the properties is all, it should be classified according to profitability, with the field having the potential to bring high benefit when optimized. It is possible to consider modernizations, installing more sensor for data collection and processing. And the second thing we need to consider here is research of blockchain, big data, AI, artificial intelligence, and machine learning. And for oil and gas, for downstream sector of it is possible to install more sensor in processing plants, because it will accelerate data collection and analysis and support operation with the goal of reducing breakdowns, downtime, and optimizing operations. Also, safety, optimizing safety index and improve the operational efficiency. And also, we may also consider a solution to optimize the sharing of equipment, spare parts, or replacement tools, forecast and use, maintenance and repair service, on a data sharing and integration platform. And the last one we need to consider here is investing in human capital and development programs that promote new digital thinking, because a digital savvy workforce is not only a foundational enabler of transformation, but also it is a key driver for maximizing value capture. So the oil and gas industry has been greatly impacted by digital transformations, and that's all I want to share with you. Hopefully you will find some useful information in my presentations. Thank you very much for taking the time to listen. Thank you.
Thank you very much, Ms. Leung Hai Lee, for your very enriching presentation. So we are now open for questions from our audience, from Ms. Ling. So while we are waiting for some questions from the live audience, I will be reading questions that we got during the registration of our participants. So Ms. Ling, for my first question, please give us some examples of firms digitizing their physical assets.
Yeah, thank you. Thank you so much for
very tough question.
Okay, so you can see my my slide now, right?
You can share your screen, ma'am.
Okay.
We can see your screen now, ma'am.
Okay, thank you. So, talking about the example of film digitizing the physical asset. So, physical asset, we can as I said before, we have 3 main stage, and the last one is digital to physical. So an oil and gas company could optimize its physical operating environment and adopt new capital models in 3 stages. With the state robotized, with the problems such as tough, riskier operating environment in offshore location, such as rigs, platforms, FPSOs, or underwater installations. Such as the solution here is robotization of platform. And I can give an example of Woodside Petroleum. They are combining its cognitive science technology with NASA, a humanoid robotic system, and they use this humanoid robotic system to ultimately design offshore facility for robot-only interventions and operations. And with the state correct, we can see here in the stage 9 correct. With the problem reducing downtime and optimizing supply chains for standalone parts, such as offshore riser, gas nozzle, or sand screen, subsea injection tools, or drill bit. The suggested solution here is laser scanning and 3D printing. And for example, Baker Hughes company is working to reduce downtime and optimize supply chain associated with the sourcing of complex customized parts such as production pump impellers. And with the stage virtualized, we can see here in this model is the stage 10. With the problem maintenance, structural and integrity of long-lived offshore assets such as rigs and platform, FPSO, ship and vessel, or also we have a LNG facility or subsea equipment. The suggested solutions is living model of physical asset. For example, the Axelos company helping Shell company, you know, right? Shell to advance its offshore structure integrity by the combining structural simulations with sensor data on rigs and big data analytics in the cloud. Yeah, that are some example I can give to you. Thank you.
Thank you very much for that very important information. Yeah, digitalization is really necessary, not just for oil and gas, for actually for all the industries right now. So thank you for that info, ma'am. For the next question is, how are oil and gas exploration and production using digital technologies in Vietnam today?
Yeah, thank you so much for.
Thank you for, sorry for giving you these very tight questions.
Yeah, I think this is a very interesting question about the technologies in digital technology in Vietnam today. So, actually the oil and gas company operating in Vietnam have been used digital technology for a long time. However, digital transformation or the applications of modern and advanced digital technology are only now beginning to be noticed. And in Vietnam, we use artificial intelligence to analyze seismic properties, interpret seismic data, analyze geophysical data to determine oil and gas potential, property of reservoir rock. And with the exploration phase, during the construction of exploratory and appraisal wells, or the documents from offshore drilling rigs are usually encrypted and transferred to data center and onshore processing center through internet. And some operator obtain well documentation by accessing a database on engineering service business store in the cloud. With the development and production phase, operator have a production data management system, or we can say a BDMS, real-time data transmission of well in onshore field to the onshore, in offshore field to the onshore, using transmission line service provided by telecommunication enterprise. And some typical oil and gas projects have been applied advanced digital technology. I can give an example here is in 2028, Hoàng Vũ GOC and PVEP put on the unmanned wellhead platform to produce oil in Cá Ngừ Vàng field in block 9092. The platform the rig is connected to the central processing platform of Bạch Hổ field in block 091 of Vietsopetrol, or in 2019. Vietsopetrol put into the rig BK20 to produce oil at Bạch Hổ field in block 091, and the rig is designed in the form of an unmanned wellhead, which is remotely controlled from the central processing platform of Bạch Hổ field. Yeah, and with the scientific research, PVU, Petro-Vietnam University implements a science and technology task research on building an artificial intelligence system integrated with petroleum geological database to assess oil and gas prospect. And so those are some my insight on the application of digital technology in oil and gas exploration and production in Vietnam. And I hope that this information helps you well.
Yes, very well answered, Ms. Ling. Thank you very much. Okay, thank you very much, Ms. Ling, for that very informative presentation and sharing your knowledge to all of us. Ladies and gentlemen, from the Faculty Petroleum of Petro Vietnam University, Ms. Loong Hai Hinh. Thank you very much, Ms. Ling.
Thank you so much.
Okay, so I am very privileged to introduce our next speaker. Our next speaker who will be presenting the self-serve to productive analytics, the benefits and practicalities of a layered approach to analytics and oil and gas. He is currently the senior pre-sales engineer based out of the Aviva Singapore office. He works closely with clients of all sizes within the Southeast Asia region and advise on how Aviva operations portfolio can integrate with corporations' digital or data transformation initiatives. His 10 years of experience and advisory experience in the PI system spans to power industries across Oceania, Southeast Asia, India, Hong Kong, and Taiwan. Ladies and gentlemen, the senior pre-sales engineer from Aviva, please welcome Mr. Michael Liu. Mr. Michael, please.
Okay. Hi, everyone. Let me just share my screen.
Yes, sir, please.
Yes. Okay. It's come up on your screen yet?
Yes, it's audible now, sir.
Okay, great. All right. Thank you. Thank you for the introduction. Hi, everyone. Good afternoon. My name is Michael. I'm from Aviva, Southeast Asia, and here I'll be briefly going through the exciting things we're doing with analytics in the oil and gas industry in this region. So as the previous presenter mentioned, there are so many initiatives that we can start off. So what I'm going to present is really just centered around the digital asset management portfolio under how to maintain your asset and how can analytics be used to do maintenance for your assets, as well as going into the future using the predictive analytics that we have in Aviva as well. Okay. So first, just introduction of Aviva. We are a global leader in digital transformation. So we have been around for many, many years, and we're on the London Exchange as a public traded company. And with the recent acquisition of OSIsoft, now we are unifying two world-leading industrial software, and we're aiming to become the market leader in industrial software as well. Okay, and as some of you or may have or may not have used OSIsoft PI system in the past, we consider as an industry standard for industrial information management. And also from Aviva, they are looking at comprehensive industrial software that manages and optimizes engineering and operations. So with the combined power of two world-leading software, we are able to look at end-to-end solution that helps you to design, operate, and optimize your work processes. So what our products are really trying to enable is the big data, industrial IoT, the cloud technology, artificial intelligence, and also enable digital twin within your operation and corporation as well. So the end goal that we are trying to achieve is really to create a digital twin of your operation as well as your entire business. But what we need is really to empower the teams that you have on the ground with the technology that we can supply. So like what we mentioned before, these are the key trends or technology trends that many oil and gas companies are going into. And we are designing our software to cater for those, where we help to, again, going through from designing, building the plant and going to operating the plant and optimizing whilst operating as well. And we have separated our product to support specific KPIs around 6 core business units, where it includes operational control, simulation learning, and more specific I will talk about is asset performance, which is a very big core part of the business that you are in. And with technology and the business process combined, we are looking at connecting your workers with the data that is stored within your corporation and how to enable them to have the information they need to drive day-to-day business decisions. Okay. So what we are seeing in our customers in recent years is really the transformation of the companies. Traditionally, we do have engineering, operation, IT, and upper management working in silos where they are using different applications and also having different business workflows to drive their KPIs. But we are seeing more and more in the recent years that they are forced to collaborate due to volatile landscapes and also situations like COVID, that we are looking at people working remotely as well as differently in the workplace. So we are ensuring that these digital technologies can be used by our customers to ensure everyone in the corporations work on a single platform, and that leverages these technology trends. And this is particularly very important where everyone in the corporation understand what the company is trying to drive and what we're trying to do. And this also enables remote working more efficiently with the situation COVID, where you can digitalize your operation in a virtual way, so you don't have to be physically there to monitor the physical assets. Okay, so with the asset performance management portfolio under Viva, we are looking at supplying from beginning to developing your asset strategy that involves the people you have, the process you have, as well as the system that collects the data, to using the asset analytics in the software that you have to design your digital twin, as well as putting some alarms and events to capture those core downtimes and etc. So you can analyze later to actually forecasting potential faults in the future that drives your maintenance strategies and maintenance execution as well. So from developing strategy to implementing what you want to do, as well as issuing work permit, you are able to looking at your asset in a whole new different way. So many times we have talked to our customers that they are looking at different options of doing maintenance. We are looking at 4 core maintenance options in the field, going from reactive to predictive, where is the latest trend that we're going into, where reactive means that break fix, we're really running the asset to fail before fixing. And the next step they're looking at is trying to do preventative maintenance, where this is more calendar based, where maintenance teams will go into the plants and do a timely schedule maintenance routine. And then once you do have the data of the assets you're monitoring available and in an accurate manner, we can looking at changing or modifying your maintenance routine based on the condition that that is monitoring those assets. And when you have collected enough data on those particular assets, we can actually supply that data into an advanced pattern recognition application that gives you potential faults that could happen in the future. So you can actually, incorporate that into your strategy. So you don't have to over maintain or under maintain. That way either give you absorbing downtime cost or absorbing maintenance costs as well. Okay. So if you're not having moved into, conditional-based maintenance or CBM, this is the challenge you're facing with the calendar-based maintenance. You are looking at either too infrequent maintenance where there's not enough, where it leads to catastrophic failure, a massive downtime that basically could cost you millions of dollars to replace, as well as the time to bring your operation up. Or you could be looking at too frequent maintenance that is sometimes just waste of time and resources, where there's certain assets that runs perfectly fine, where you are doing maintenance and bring it down for safety or preventative reasons. So this is the kind of the balance that we're trying to strike with our customers, that what is enough? That is the key question we're looking at by utilizing the software that we have and the data they have. So this is really what we're trying to find the sweet spot for our customers to reduce the maintenance costs, to find the middle point or the sweet point where there's enough maintenance for the assets to run perfectly, for the equipment to run smoothly, and reducing minimum downtime, as well as improve overall equipment efficiency, or the OEE, so the equipment can perform at the maximum capacity to drive best business values. As well, at the same time, we're capturing the knowledge of the assets with the aging workforce, where we can actually use data to simulate what the equipment will be running and allow the next generation workforce to come in and learn about the equipment without actually being around the equipment. So that's essentially what we're trying to drive with this products that we have. So what I will do is, give you, I guess, example of what we do with our analytics. So under Aviva, we do have a lot of interfaces and connectors that allows us to connect to the data source that's in the control layer. So this is not restricted oil and gas. We have these connectors that's connected to common protocols, such as PLCs, OPC servers, and include some IoT devices. And what we do is try to pull that data into the Pi server, or the Pi Data Archive, that is the leading market data repository. So we can have 100,000 or 100,000 or millions of data points that basically monitoring your assets around different sites or different countries. Then you can do some very smart, intelligent algorithm around those. So once we pull the data into the Pi Data Archive, we basically assign some context and building the digital model. So we'd like to start small, maybe start with efficiency, where to a pump, the efficiency equals from float rate times the pump head divide the horsepower. So this basically gives you the efficiency of the equipment that you have. And what we want to track is really when the equipment efficiency goes below a certain time. And that's quite important to us. And we want to build that into a logic, as well a template that can apply across multiple assets of the same type or the same manufacturer. So over in here, we basically looking at a pump template with the attribute and property of the status of the pump, which includes the runtime, how long it has been running. And then we also have the data coming from the plant, which is discharge flow rate, as well as the OEM data that comes from the turtle heads, as well as the horsepower that it can produces. And with these parameters, we'll be able to calculate how long the pump has been running and what is the efficiency over time. Okay. So once we have that calculation built into the Pi system, we can actually design or create a pump efficiency as a threshold or set point, where we monitor this particular equipment's efficiency until it drops below 75%. And then when that happens, we are looking at capturing that particular time and bookmark that time where it's considered a Pi event frames when the equipment has been performing under what it should be. And then rewriting the logic is really simple, using the element or the template that we have as a pump 01. We've used the attributes, pump status, the flow rate, and the horsepower and total heads, and produce the analytics that includes the run hour, how long it's been running, and what's the pump efficiency in real time. And then through the event frame we are looking at the expression of pump efficiency. It goes below 75%. And if it's true for 10 minutes, we will capture that event. Okay. And that's basically how we, build a digital model, execute the logic behind the model. And then final stage, when this does happen, we want to notify someone to look into or notify a system to look into as well. And once we build this logic and the model together, we apply the template to all similar assets. And this basically propagates through all the assets that you have of the same type of equipment that you have as well. Then you have a whole fleet that's been monitored by a single template that's based on the same digital model, as well as the algorithm that monitors the efficiency of this. And going a bit further, we are using the notifications that contains specific data to the assets and pass that information to a computerized maintenance management system that could be SAP or IBM Maximo, where it actually, stores the maintenance data or trigger a work order to actually implement for future for the maintenance team to execute later. Okay, and the same thing can be vice versa. We can actually bring the runtime that may be stored in a CMMS back to Pi. So there's also bidirectional synchronization between the two systems that kind of helps even improve further of your maintenance strategy. And overall, in a few very simple steps, we are looking at an overall of visualization of your pump station that contains multiple pumps of running the same parameters. So you can look very quickly in the visualization platform how your pumps are actually performing. And this also applies the same. The pump station also can be temporalized, and this can be applied across your whole site or multiple sites or across regions as well. And this is the same with your oil and gas plant refineries, where we actually have multiple pre-built assets available for you to look into. Okay, so that is starting from scratch. What we have just covered is really the industrial information management layer. So on the operational side, we have the analytics that allows you to build from scratch if you don't have it already, and you can build your digital assets very quickly and add up for your visualization. But in the overall scheme of Aviva portfolio, we do have, asset performance functions specifically to help you to monitor your assets. So what we call is the APM, Asset Performance Management Blueprint. And what I've highlighted here is really, the different components in APM that helps you to drive your asset maintenance strategy and execution. So overall in APM, we have the asset strategy optimization. So this really helps you align your asset strategy with your enterprise goals, which assets are critical. We have SMEs that kind of work with you to look at whether your current asset strategy is optimized to what you want to do. And once we do have that, we have configured the asset analytics where it reduces, where it uses predictive AI-driven predictive algorithm to do analytics to give you early detection of faults. So this is artificial intelligence driven and machine learning driven application that gives you alarms and notifications around potential faults where they analyze the operational data versus the forecast or predicted data, and they are looking at the difference whether your asset is operating within this means or outside of the operating window. So this also gives you very good insight around whether your assets will be performing well in the future, where what we have mentioned before is how your assets are performing in real time. Okay, and then thirdly, we do have asset maintenance application that helps prove safety and reliability. We do have application that helps you to issue work permits and also doing hazard analysis around your assets maintenance routine. And then with all that, we also have an asset information management that helps you to consolidate all the data into one single location. So this includes your engineering data, operational data, maintenance data, as well as 1D, 2D, and 3D drawings as well. Okay. So with all that combined, we are looking at connecting all the analytics together. So what I show at the beginning is conditional management. So you have your current real-time data stored in the Pi system that enable you to do conditional-based monitoring, which is also conditional management that helps you collect the asset conditional data, as well as generating automatically generating the work orders for execution. The second part we are looking at is really the predicted asset analytics that helps you and continue to be able to feed the real time coming from the Pi system and allow the AI-driven algorithm to predict future faults based on the difference between real-time operating data as well as predicting data. And once you do have that, you can send alerts and create use cases that allows others to act on as well. And then the other thing we're looking at is also, AMI, asset information management, where it actually give you a whole context. Everything around the equipment includes, the operating data, the forecast data, the 3D drawings, and et cetera, et cetera. So this basically allows you to look everything around your assets in a single platform. And then once we do have that, when we do have the whole holistic view, we are able to, looking at we are able to convert the PID drawings into 3D models, such as what you see here, and prepare your design for operation. So there's a smooth handover between engineering team and the operating team, between using the AVEVA engineering tools and the Pi system. And then we also have the application that connects the workers to do manual entry or work permits and issue, also allows other users to work remotely or from working from the iPad. So our tools is basically connecting everyone from on-site all the way from design to operation, as well as those in the office. So the whole applications are built together to enable everyone from top to bottom to see the assets in a single point of view. And this is just a AVEVA portfolio. So with the OT and IT convergence, we are looking at connecting visualization together between different systems as well. So we are looking at connecting the ERM, the CRM, as well as financial data within your operating environment, as well as the engineering design environment. So over here is that you can have a whole panel that shows everything that you are monitoring within your corporation, that basically combining your people, the information you have around the assets, as well as the work process together as well. So essentially, we bring all together into a single source of truth that allows you to look at your data, not only from data point of view or asset point of view, but also geographic point of view, and also videos as well. So this basically combines all your analytics, all your algorithm, all your asset information into one single pane of visualization, and this gives you gives the entire enterprise the same view on everything. Okay. So one case that we do have is SCG, who basically work with Viva to create the digital reliability platform. So this is, again, one of the initiatives they have around digital twin to actually monitor the assets across all 15 plants, and that is the end goal. So how can they improve efficiency, reliability, and safety across all plants? And they are basically working at Viva to bring that information from the operating data into predictive analytics. So it allows them to create a platform that they can view all the assets across all the plants. And basically this won the hydrocarbon processing award for the best monitoring technology out there. And this is one of the examples that we have that helps our customers to not only improve the work, to improve their processes, but also monitoring the assets. Okay. And the next section we have is also Petrobras, basically also uses technology as a strategy to drive a connected workforce. So Petrobras have a lot of these FPSOs around the different parts of the world. So how can we utilize the technology on board as well as the technology offshore to connect people remotely to monitor their assets over here? So this is actually utilizing, again, Aviva technology as well as products to enable workers and issues work permits to allow them to work on site based on the condition they have offshore. Okay, and there's many examples that we have. So do reach out to us if you do have any questions, and that basically finishes my presentation on that. And thank you very much for your time.
Thank you very much, Mr. Michael, for the very informative presentation. So we will now come to the question and answer part. So Mr. Lu will be happy to answer all your questions. So once again, you can use the chat box on the right part of your screen. Then you can type in your message, click on the drop down next if you want to send the message. So while waiting for the audience to send their questions, I will be reading some questions that we got from the audience during their registration in our webinar. So with that, okay, Mr. Michael?
Yep, that's fine.
Okay, so I'll be reading the first question. Here it is. Is there any programming involved in the analytics you've shown?
Okay. There is no programming involved. So all the analytics I've shown is basic self-serve, like what we mentioned. So both what I show, the Pi analytics side, as well as the predict analytics side, are all built for point and click. So really only basic computing knowledge is needed. There is no in-depth programming or configurations needed. So we do have very simple interface that allows our customers to build their own analytics.
Okay, very well said, sir.
Yep.
Okay, for my next question, do you provide any pre-built model templates?
Yep. So in the APM portfolio, we do have templates that are supplied to our customers, especially around the predict analytics. So we do have a good portion of rotating equipment that allows our customers to look into. But we also offer a workshop that basically helps our customers to design their own template as well. So if that is not included in our portfolio already.
Thank you very much for that answer, sir. Okay, so let me read. I still have here one more question. Okay, so how much data is normally needed to train Aviva predictive analytics to produce a good prediction?
Okay, yep, that's a very good question. Yep, so like I mentioned, I think with a good prediction, we do need a good amount of data to actually see what the normal operating state is for the assets. So a good amount that we normally recognize is around 6 to 9 months of data that you've collected. And this is just a very small portion of what the PI system is capable of. So if you do have 6 to 9 months, we can be pretty confident that this will give us a good start to give you a good prediction on the asset values.
Okay, thank you very much, Mr. Michael, for that very informative presentation and for answering all the questions that we got from our audience and for, of course, sharing your expertise to everyone. So, ladies and gentlemen, Mr. Michael Lu from Aviva. So other questions or recommendations will be consolidated and will be forwarded to our presenter after our webinar. So ladies and gentlemen, that all ends our webinar today. Once again, we would like to express our thanks and gratitude to all our guest speakers in today's online event. So once again, I would like to thank our sponsor, Aviva Software Solutions for Oil and Gas, and to Petro Vietnam University for the very informative presentation. So we have now come to the end of our session. Once again, would like to thank our speakers, sponsors, and audience for joining us today for this very productive and informative webinar. Once again, thank you very much, and let us all stay safe always. God bless everyone. Thank you.